The third lesson in Unit 3 is writing inequalities from a word problem. There isn't much difference between writing an equation from a word problem and writing an inequality from a word problem. You're still pairing all your information, making sure we're putting the x on the right value. You're still going to have two halves. The only difference between writing equations and writing inequalities is the comparative phrase between the two halves of your equations. In an equation, the comparative language always results in an equal sign, telling you that the left half of the equation is equal to that of the right half of the equation. In an inequality, you're going to use comparative words such as greater than and less than, greater than or equal to, less than or equal to. So in this case, when we're working with inequalities, one part of your equation is always going to be larger than the other. And it's important that we not only pair our information correctly, but also put the equation on the proper side of the comparative phrase. So that's what we're going to focus on today, because everything else in writing equations and inequalities is pretty much the same lesson. So here across the top, we're going to list the comparative phrases and the symbol that we would use to represent that mathematically. So first, we have less than. Our symbol for less than faces this direction. Second, we have greater than. The symbol for greater than faces this direction. Third, we have less than or equal to. And that's the less than symbol with a line beneath it. And then we have greater than or equal to, which is the greater than symbol with a line under it. These are going to be the four options we have to represent our comparative phrase. So let's look at the first problem. It says the table compares cell phone plan rates for two companies. Write an inequality that can be used to determine the number of months it would take for Cell Sensation to cost the same as Cell Nation. For some reason, the table did not print off on the anchor chart, so let's go ahead and write that out together. We'll just fill it in right here at the bottom. Okay, so on the information for Cell Sensation, it's going to cost them a $70 activation fee and then $49.95 a month after that. For Cell Nation, it's going to be an $80 activation fee and $37.95 per month after the activation fee. Go ahead and fill that chart in for yourself, and then we'll start color coding and pairing our information just like we would in an equation. So I accidentally recorded half of this anchor chart without hitting the record button. So I'm going to pull the sticky note out of the way and walk you through the steps I went through. So we're pairing our information over here off to the side. So I have my cell sensation information here. I broke it down. We have a $70 fee and $49.95 a month. We're going to skip for a second over our comparative phrase and we'll come back to it. And then we have our Cell Nation information, which is $80 fee and $37.95 a month. Looking up here, it says that we want Cell Sensation to cost the same or more than Cell Nation. So as I said when we did the equation paper, it's not super important when we're looking at equations to color code our comparative statement because it's going to be equal to. It doesn't really matter which information ends up on which side of the equation because it's going to be equal. We just need to make sure we're putting the correct information on the same side of the equation. When it comes to writing an inequality, you need to make sure not only are you pairing your information correctly, but you're also writing it in the correct order for the statement to be what the equation or the inequality is looking for. So this says that Cell Sensation is going to cost the same or more than Cell Nation. So the way I write this is CS in the pink color that I coded CS with, same or more than, and CN written in the same color that I coded that information with. Because I can look at this and say, when I write my inequality out, I need my pink information, the comparative symbol, followed by my purple information. That way I'm making sure I'm pairing it correctly. So now we're going to translate this information over. Before we can translate it into a mathematical format, we need to determine where our X value is going to go. And again, we do that by referencing what they're asking about specifically in this inequality for us to compare. They said, write an inequality that can be used to determine the number of months it would take. So the comparative information they're wanting us to look at is the number of months, which means if we see per month as a label on the number, that's where our X value, our exponent, is going to go. So when I translate this information over for Cell Sensation, I have 70 is my $70 fee. That's going to happen one time and can be represented with a plus sign. And $49.95 per month. That's the key phrase we're looking for based on what they've asked about. So the $49.95 is going to get our X value. Okay. Again, we're going to leave that comparative phrase alone for a second. Now here I have my Cell Nation information translated over. That $80 fee is just going to happen one time, so it's just 80. It's not a monthly thing. There's no exponent. And $37.95 a month. That per month is what they've asked us to compare. So per month is our exponent, so it is plus $37.95 per month. So when I write my comparative phrase, I'm again going to use the color coding. I'm going to write my CS with the pink that I originally color coded with. I have my comparative phrase in the middle. Same or more than is this greater than or equal to symbol. And then I write cell nation after that comparative symbol in the same color that I coded cell nation with. Again, to remind myself, it's my pink information followed by greater than or equal to, followed by my purple cell nation information. So when I write it out horizontally, it looks like this. Sorry about that, guys. Okay, so let's look at this second problem. This says if you pay a one-time fee of $30, you can buy a ticket for a music concert at a reduced price of $17. Regular tickets cost $25. Excuse me, write an inequality that can be used to determine the number of reduced price concert tickets you would need to purchase in order for the total cost to be less expensive than the same number of regular tickets. So in this case, we have regular tickets and reduced cost tickets. So if you pay a one-time fee of $30, you can buy reduced price tickets for $17. Our regular tickets cost $25. So that means, again, I'm going to use a list this time so you can see one of each format. So here I have my reduced price tickets. Over here, I'm going to have my regular price tickets. So for my reduced price tickets, if I pay a $30 fee, I'll then pay $17 per ticket. If I don't pay the $30 fee, I'm just going to pay that $25 per ticket. So now I need to pick out my comparative phrase. Write an inequality that can be used to determine the number of reduced price tickets you would need to purchase in order for the total cost to be less expensive than regular tickets. So I want reduced to be less expensive than regular. So here I have reduced less than regular. Okay. Now I'm going to translate my information mathematically. In order to figure out where my x value is going to go, I need to reference the question one more time to see what they're asking about specifically for me to compare. Write an inequality that can be used to determine the number of tickets. So my exponent is going to be represented by the word tickets. So let's translate this stuff mathematically. That $30 fee, it's going to happen one time. So we have 30. And then I'm going to pay $17 per ticket. That's what they asked me to compare is the ticket, so that's where my x value goes. Over here, regular price is $25 per ticket. Again, that's what they asked me to compare. That's my x value. And I want my reduced tickets to be less than my regular tickets. I need to translate this mathematically, which is which symbol? That's our less than symbol. And there is the inequality for this second problem. Let me box in the inequality for the first problem. So there you have it. Again, you're breaking things down mathematically the same as you would when you're writing the equation. You're pairing your information just like you would if you were writing an equation. The only difference is the comparative phrase and comparative symbol that you use in the middle of your two halves of your equation or inequality. In an equation, it's always going to be an equal sign. In an inequality, it's going to be one of these four, and you just need to pay specific attention to where you're placing your information to make sure that you have your inequality saying exactly what they're asking for it to say within the word problem. Go ahead and work this problem here at the bottom by yourself.